All right, box plots. So it is a graphical representation of the distribution of data sets that displays something. Okay, we will decode and go deeper into what is that something. Okay, but you have to understand that there are, in God we trust, rest of them bring data. It is a Six Sigma is a data-based decision making methodology, data-based decision making, not gut feel based decision making, not experienced based decision making, not consultation based decision making. Okay, it's a data-based decision making. That is why I always say, in God we trust. Rest of them, please bring data. Okay, when you bring the data, you need to make sure that the data is represented graphically. Okay, data has to be represented graphically. Visual representation of the data will help you in better analysis than just showing some numbers. How many of you agree with me? That is why even in safety related in roads, you see a lot of visual signs, so that visual interpretation, the mind can recognize much faster. Okay. Now choosing a graphical analysis. Now I said we have to bring data. The data is of two types. One is continuous. The other thing is discrete. Okay. Discrete means count 2, 3, 4. Continuous means 2.1, 2.2, 2.3, 2.12, 2.13 and stuff like that. If this is clear, type super clear SC in the chat box. There are two types of data. Fantastic. All right. Now let us go deeper. Now when it is a continuous data, like weight, height, temperature, pressure, okay, we need to see what type of visual thing that you want to see. You want to see the summary statistics, graph and summary statistics, or you want to see the graph only. If that is true, there is something called as a graphical summary. Okay, there is something called as a graphical summary that we can put in a software called Minitab. Whereas if you want to see graph only, you wanted to ask the next question. You wanted the summary of data, or you want every data point to be represented in the graph. Okay, if you want every data point, it is called individual plot. And if it is a summary of data, you want to ask what do you want to examine. If you want to examine the distribution, or you want to see the center of the data and the spread of the data. If you want the distribution, you do histogram. If you want center and spread, you see box plot, and box plot is what we are going to see today. All right, now I'll go ahead. In the discrete data also, you need to see the objective. Do you want to identify the most common type of defect? It is Pareto analysis. Last time we have done Pareto analysis. But if you want to compare the data categories, you want bar graph or pie slices, you can use bar chart and pie charts. And you see so many graphs, 1, 2, 3, 4, 5, 6, 7. 7 graphs. When you use these 7 graphs is displayed in one particular slide, step by step. Introduction, box plots. Okay. Now what is box plot? The definition, if I want to see, it has got a box, okay, and it has got a whisker. What is whisker? You know, how many of you know cockroaches? How many of you know cockroaches? Yeah. The cockroaches has got how many whiskers? Antenna, yeah. 2 whiskers, right? How many of you know the cats? The cat has got how many whiskers? Many? I said cockroaches because there are 2 whiskers it has got, right? Mostly. I think so. Antennae, they call. And box plot is also known as a whisker plot because not only box, but also whiskers are there. This yellow color and stuff like that is box. Another thing is called as a whisker. Okay. All right. Right. Now, the box plot is a standardized way of displaying the distribution of data based on 5-number summary. Okay. All of you type 5S in the chat box. It is a 5-number summary. It's a 5-number summary. Okay, good. So the purpose of this is provides a visual summary of the data, variability, and potential outliers. Visual summary of the data, variability. You will soon see how it shows the visual summary. Okay, and potential outliers. When to use it? If you want to compare distribution and identify outliers. So one of the best ways and quick ways and very reliable ways of checking the distribution is through box plots. Okay, let me go deeper into the components of box plot. In the box plot, you see a box here and you see a center line here. This center line is called as a median. All of you write CL is equal to median. Please take good notes because I'm spending my valuable time. I want you to make the best use of it. CL is equal to median. Okay, the end of the box is LQ and UQ. Okay, all of you type LQ and UQ. LQ is lower quartile and UQ is upper quartile. And the center is the median. Super. And beyond LQ and UQ is called as a whisker. All of you type W for whisker in the chat box. So you have learned 4 things now. You learned center is a median. You have learned lower quartile, that is the beginning of the box. The end of the box is the upper quartile, and whatever is the whisker that is coming out, antennae that is coming out, is called as a whisker. Okay. And then you have the maximum data and the minimum data, which is upper extreme and lower extreme. Some people call maximum and minimum. And there is a point here. Normally it is represented by asterisks. Okay. It is called outlier. All of you type outlier in the chat box. It is normally represented by an asterisk, a star. Okay. Outlier. All right. I hope you have all taken good notes. These are the components: median, lower quartile, upper quartile, whisker, maximum, minimum, and outlier. These are the 7 components that are there. Okay. Now, maximum is the smallest point. Okay. Maximum is the smallest data point excluding the outliers. Okay. The first quartile is the lower quartile. It is called Q1. Okay. All of you type Q1 in the chat box. All of you type Q1 in the chat box. So the lower quartile is called as Q1. The median is called Q2. All of you type M is equal to Q2. The median is Q2. And the third quartile, upper quartile, is called as Q3. Now, why am I using the word upper quartile, third quartile, Q3? Why don't I use only one particular word? Because many books, it is written in different forms. As long as you understand, it is okay. Maximum is at upper extreme. Okay. And whisker is what is extending from Q1 and Q3 to the maximum and minimum. What is extending from Q3 to the maximum and Q1 below that minimum. Okay. And outlier are the data points that fall outside. Outlier are the data point that falls outside. Outlier is 1.5 times. Okay. The interquartile, Q3 minus Q1. All of you type Q3 minus Q1. That is called IQR, interquartile range. The interquartile range is between this box. That is Q3 minus Q1. Upper quartile minus lower quartile, or third quartile minus first quartile. All right. Now the question for you. How many of you are ready for Q&A session? To type ready in the chat box. How many of you are ready? Awesome. Okay. Be ready. What does the box plot primarily represent? The mean of the data set, the frequency distribution of the data set, the 5-number summary of the data set, and variance of the data set. What is the right answer? All right, we all know C is the right answer. And for those who have typed C, all of you send chocolates, flowers, because the 5-number summaries data set is the right answer. Okay, what is that 5-number summary? The statistical summary of the data set that includes, okay, let's focus back. The statistical summary of the data set includes minimum, Q1, median, maximum. Okay, so now when the data is arranged in the descending order or ascending order, okay, the middle point is called as a median. Okay, so when there is 100 data points, the Q1 start from the 25th point, okay, and the Q3 ends at 75th point. It's called 75th percentile. And it's used to determine the structure and appearance of the box plot. This is called as a 5-number summary. So let's understand this. We already said that each of this is divided into 25%. This portion 25%, this portion 25%, this is 25%, this is 25%. Okay. More number of data points here, 25% will be here. Okay. It is all equally distributed, 25, 25, 25. Just because the length is more, it doesn't mean that it has got more percentage. Okay. Once you, when I will show you histogram and the box plot, you will understand what I'm saying. When this median and the lower quartile is short, it only means a lot of data points here. Okay. Again, 25% whisker, 50% is the interquartile range, which is the box. It is divided by the median, which is 50% of the data points here, 50% of the data points here. If the box is, if the line is not in the middle, it only shows that it is little skewed here. Okay. We will understand what is skewness and kurtosis. Okay. And then 25% of the point here. So the interquartile range, upper end of the box is the third quartile and lower end is the first quartile, and Q3 minus Q1 is the interquartile range. Let's ask some questions now. So in this 5-number summary, see, you can either represent like this. Okay, box plot can be vertical or horizontal. Doesn't matter. It is just tilting of the box. That's all. So I wanted to show you 2 formats so that you understand well. Okay. So this is the interquartile range. 25% of the data points is here. Median need not be in the center. Okay. The whiskers need not be of the same length. Okay. But this is just showing that, okay, to help you understand. Okay. So this is the box. This is the first quartile. This is the third quartile. This is the median, which is Q2. This is maximum, minimum, which is Q0 or Q0, and maximum, which is Q4. Okay. So far, if this is structure of box plot is clear, all of you type SC, super clear, in the chat box. All right. Now I'll ask you some questions. For those who are typed super clear, I'll ask you some questions. So this is a question. Which of the following is not a component of box plot? Which of the following is not a component of box plot? Median, mode, first quartile, outliers. I know all of you are ready with the chat box to pump in your answers. Go ahead and do that, please. So for those who typed B, it's absolutely right answer. You deserve a lot of chocolates today. You deserve a lot of flowers. The correct answer is B, which is mode. Okay. Okay, for BO, thank you for sending a lot of chocolates there. All right. So different parts of box plots we have seen. I just wanted to explain you one more time with a little bit of more detail. I have explained you this Q1, Q3 minus Q1, which is 25th percentile, 75th percentile, and it's the interquartile range. But I also want to tell you that Q1, this particular thing is Q1 minus 1.5 times the interquartile range. Okay. And Q3 is 1.5 times the interquartile range. Outliers. Okay. I'll help you understand in the next slide. Before that, I just wanted to ask you a question on what does the line inside the box plot represent? Okay, mean, median, mode, and variance. What does the line inside the box plot represents? I know in the box you divided into a line. Okay, what does that represent? Yes, the correct answer is median. Fantastic. All of you are observant here. Okay. Interquartile range. Okay. What is interquartile range? All of you put in the chat box. I've explained you many times now. I'm asking you one more time. What is interquartile range? Q3 minus Q1. Okay. Good. All of you awesome students here. Okay, the definition is Q3 minus Q1. The importance of this is measure the spread of the middle 50% of the data. That is what you have to understand. The importance is it measures the spread, which is the 50% of the data, and Q3 minus Q1 is a calculation. And now I will understand points beyond 1.5 times IQR. I repeat, points beyond 1.5 times IQR from the quartiles are considered outliers. Please write it in a notebook, because there in that picture I was not able to explain you when I had marked in the outlier, but here I wanted to let you know that points which are 1.5 times the IQR, which is Q3 minus Q1, from the quartiles are considered outliers. If this is clear on a scale of 1 to 10, please give me a 9 or 10 if it is super clear. It's very important to know how the outlier is determined. Okay, even if it is a software will show the outlier. Okay, of course this needs a bit of practice. Most of the software gives you the outliers, don't worry about that. Okay, the interquartile range is defined as Q3 plus Q1, the difference between Q3 and Q1, the sum of minimum and maximum values, the difference between maximum and minimum. Easy answer, right? So many times we have revised this. All right. So Q3 minus Q1 is the right answer. All right. Now I'm showing the same graph again. So whatever is beyond 1.5 times IQR, you calculate Q3 minus Q1, multiply that with 1.5. Okay, and if that point is beyond that, then you call it as outliers. Data points that fall, because somebody wants me to explain again, data points that fall significantly outside the typical range of the data set. And what is that range? Outliers are marked with beyond and any value that is less than Q1 minus 1.5 times IQR or Q3 plus 1.5 times IQR. Okay, that is called as a whisker. Okay, the formula is, I mean, if you don't understand still, please go ahead and research in ChatGPT. Please go ahead and research in YouTube or the net. Okay, any value less than Q1 minus 1.5 times IQR or Q3 plus 1.5 times IQR qualifies for what is called as an outlier. Now, for those people who didn't understand before, now if it is super clear, give me a 9 or 10 if it is super clear. And still, if you don't understand, it's okay, because not all of us are on the same page or same level. Okay, please go ahead and research on ChatGPT, internet, or whatever it is, and try to understand it beyond this. Super clear this. Very good. Which of the following best describes an outlier in the box plot? A value less than the first quartile, any point outside the whiskers, the smallest value in the data set, the value larger than maximum in the box plot. Let's see the answers. Any point outside the whiskers, okay? Whisker ends and outlier starts. After that, beyond whisker. All right. How are outliers determined in the box plot? Just now we've been explaining a long time, right? Any data above Q3 or below Q1? Any data outside 1.5 times the interquartile range from the quartiles? Data points that lie within whiskers and data points with extreme frequency. Naturally, right? You explained that enough. So you got the right answers. That's what is the right answer. How to read a box plot. We have explained enough number of times. I will explain one more time. Interpretation, where does the median lie? Indicates the center of the data set. Spread of the quartiles, wider the boxes implies higher variability of that range. Length of the whiskers shows the spread of the rest of the data. And summary of skewness, compare the length of the whiskers and the box to see the skewness. Shorter, longer, unequal length of the whiskers shows that there is a skewness in the data. Okay, now the follow-up question is just, what is the purpose of whiskers in the box plot? They represent the mean of the data. They indicate the variability outside the upper and lower quartile. They show the frequency of data. They mark the outliers. Okay, they indicate the variability outside the upper and lower quartiles. Great, awesome. So creating a box plot step by step is very easy. Again, I'm just showing this box plot. First, organize the data set. Calculate the 5-number summary. We have already explained about the 5-number summary. Then compute the interquartile range and determine the outliers and plot the box, whiskers, and outliers. Okay, so can we see some examples of box plots in different industries? All of you type BIO, bring it on in the chat box. Bring it on, BIO, bio. But you need to focus here, carefully understand this, okay? So suppose in the education industry, there are 4 methods of teaching. Method 1, method 2, method 4, method 3, method 2. Okay, 4 methods. And the score of students in which method are the variability of the students very reliable method? Which is a very reliable method in this? Which is a very reliable method in this? Stable method. Which is a very stable method with less distribution? Method 2 has got less variation. Okay, in which method people score? Okay, method 2 has got less variation. Okay, so that's a stable method. But then which method people score maximum? In which method do people score maximum? Method 4, because you see method 4, it is always on the high side. Which is the most unreliable method? Where there is a lot of distribution. Which is the most unreliable method? Method 3. Okay, good. Most of you have got know how to read the box plot now. Let me go to the next example. Let me go to the next example. It's in the food industry. Let's say in the food industry, the chick body weight, okay? The chick body weight, it depends upon the diet type that you give to the chick. Okay? So, which diet is giving good body weight to chicks? Which diet is giving good body weight to chicks? It is diet 3, okay? Because that is the highest body weight. But if I ask the question, which diet is giving less variability, then it is diet 4. If that is clear, all of you type super clear in the chat box. See, the box represents the amount of variability, whereas if it is on the higher side, it means that the diet is better here. But the distribution, the variability is very high. The variability is high. Now let's see automobiles. Number of gears, miles per gallon. There is a 3-gear vehicle, 4-gear vehicle, and 5-gear vehicle. Which geared vehicle will give more miles per gallon? 4-geared vehicle. Okay, the second one. All of you are typing 2 because you meant the second one. It's a. And which geared vehicle is showing lot of variability in miles per gallon? Lot of variability in miles per gallon. The 5-geared vehicle, right? Right. Okay. Again, automobile. You see the class of vehicle: compact vehicle, mid-size vehicle, SUV vehicle, 2-seater, the minivan, the pickup, subcompact. Okay, a lot of type of vehicles. Okay. Highway mileage in which vehicle is quite high? Highway mileage in which vehicle is quite high? You should say here the compact vehicle, the highway mileage is quite high and the variability is also less. Okay. Okay, lowest, which is lowest in terms of mileage? That is very easy to find out, right? Here, SUV. All right. So some people say pickup. Yeah, correct. Sorry. Pickup is here. Pickup is the lowest here. True. Very true. Okay. Healthcare. There is a treatment that is done where aspirin is given, ibuprofen is given, and acetaminophen is given. Okay. So the temperature is given here. Which one is which one has got a lot of variation? Very unreliable, too much variation. Ibu, okay? Okay, that's clear. So if you see here, box plots versus histogram, all of you are familiar with this bell-shaped curve called normal distribution. Type yes in the chat box if you're familiar with this. All right. So the same thing, whatever that we have, the standard bell curve that we call, if you actually want to convert that into a box plot, in the standard normal distribution, the center one is the median mean, and the 50% here is the interquartile range in the box plot, and remaining the pink portion of it is a whisker, and the green portion of it, which is outside, is called as the outlier. Okay, and there is no compulsion to understand this. Those who have understood this can type US in the chat box if you've understood. And if you've not understood this, this is beyond the scope of this. This is just the additional information that I've given. That's all. Okay, if you've not understood it, don't worry about it. So the leading question is, what is the difference between box plot and histogram? A box plot displays the distribution while the histogram shows the mean. A box plots provide 5-number summary while the histogram shows the frequency distribution. A box plot shows only the outliers while the histogram shows only the mode. And the dot plot is, the box plot is used for smaller data sets while the histogram is used for larger data sets. Let me see the answer in the chat box. Okay, B is the correct answer. Box plot provides the 5-number summary while the histogram shows the frequency distribution. So common mistakes while using box plots. What are the common mistakes? Misinterpreting mean as median, ignoring outliers, using box plots for small data sets. Do not use box plot for small data sets, minimum 50 data points. Okay, comparing box plots without considering the context of data. So these are all some. So the question is, which of the following could indicate that the data shade is skewed in the box plot? This is a very, very important question. The whiskers of equal length. The median line is at the center of the box, whiskers unequal length, and there are no outliers. I had indicated in earlier explanations. Okay, all of you type C. C is the correct answer. Okay, the whiskers are unequal length, that will indicate the median line at the center of the box is not the indicator. Okay. Okay. In which scenario would a box plot will be most useful? When you want to compare the frequency of different data points, when analyzing the central tendency of small data sets, when comparing the distribution of multiple data sets, when determining the mode of data. All right. When comparing the distribution of multiple data sets. Okay. So some summaries. Let's go into the summary, recap of key points. We've gone through the definition of box plot, 5-number summary, identifying outlier and interpreting the spread, when and how to use box plots effectively, and in conclusion, box plots offer a powerful, easy way of visualizing statistical and uncovering outliers.